Hi guys, welcome back to my series in part 2 of analytical geometry. I'm Joki Manuel. In this one, I will be taking you through the analytical geometry problem in part 2 of my series. Now, I want us to read what we have right here. We are saying that in the diagram below are two circles that touch each other externally at the point C, where C is 20 over 13 and 95 over 13. Now we also have 3 points to note here that the radius of circle A with the center minus k and 5 is 6 units. I'm going to highlight that. You have 6 units as a radius of circle A. And then the second point that the radius of circle B with the center B is 2k and 10. Right, then I'm going to highlight that radius is 7 units of that point. I'm just trying to highlight that now, which is this point, which is the center right there. And then you also have a radius right there. I mean the center A, which is minus k and 5. And then now I want us to pay attention. You have a length from here to here, which we are saying that this is 6 units. And then from here to here, it is 7 units, you know. So this is what we have. And then ABC, you also have ABC, which is a straight line joining ABC in that case. So now I want us to check something here. We are saying that if k is a positive number, prove that the gradient of AB is 5 over 2. We have to prove that the gradient of AB is 5 over 2. Okay, thank you very much for that. So what I will then do is I'm going to get the value of k, because I don't know that value of k, and this question worth 6 marks. So what I will then do is I'm going to be able to find the value of k. How do I find the value of k? I'm told that the two circles touch each other externally. What it means is, it means that the distance between AB is going to be equals to the sum of their RD. So that is the radius of A plus the radius of B. You can write that to say, well, this one, it happens when two circles, touch each other externally. Circles touch each other externally. We're going to have the sum of the radius between their centers A and B is going to be the same as the sum of their D. That is why you're given those two radius of those two circles. So then now what I will then do is I'm going to find the distance between A and B. I will then say to myself, well, B is going to be equals to the square root. I have two centers right there. So I'm going to say this is 2k minus k. So basically it's plus k right there. I have to square that, plus, and then I'm going to say, well, this is 10 minus 5, and then I have to square that. So this will then give me the square root of 2k plus k is 3k all squared. It's going to be 9k squared. 10 minus 5 is 5 all squared is positive 25, I guess, right there. So then what I will then do is I'm going to say, well, let me write that formula again. That is AB equals to RA plus RAB. That means RA is the radius of circle A. And then now what is AB? My AB, it's simple, is the square root of 9k squared plus 25. That equals to what is RA? RA is 6 units plus what is RB? RB was given here 7 units. So I'm gonna say this is 7. So basically what I have here is the square root of 2 perfect squared, which is 9k squared plus 25 equals to, if I have to sum those two, I'm going to get 13, I guess. That will be 13. Now, because now I want to remove the square root. How do I do that? I have to square both sides, just basic algebra right there. And then I'm going to have 9k all squared plus 25 equals to, when I square 13, I'm going to get 169. And now I have to transpose 25 that side, so this will then be 9k all squared equals to, what do I get there? I'm going to get 144. In that case, I have to divide that by 9, so I'm going to get k squared is equals to 16. Well, I have to solve for k a bit, so I'm going to say, well, let me square both sides. So this is going to be plus or minus a 4 when I square both sides. So therefore, because we are told that k should be a positive stuff, so I'm going to ignore the negative 4 part and say, well, this means that the value of k is positive 4. I'm going to highlight that the value of k is positive 4 in that case. So what I'm then do is I'm going to plug k in a circle center A and B. Now let's do that quickly. We're going to say, well, this means that A is negative 4 and 5. And 5 right there. So about that, I'm going to write 5. And B, what is B? B is 2k, so it's going to be 8. It's 2 times 4, which is 8 and 10. So this is going to be 8 and 10 right there. So I want to find now the gradient between these 2 points. So I'm going to say, well, the gradient between AB would be YB minus YA divided by XB minus XA in that case. So now to substitute those points, we're going to have 5. If you subtract those, it will be 10 minus 5 divided by XB, which is 8 minus 4. In that case, what are we going to have? We're going to have 5 in the numerator divided by 8 plus 4, which is going to be positive 12. So therefore, the gradient between AB, it gives us 5 over 2 as per request from the first question in our example. So this is how you guys you would go about that. And then now the second question, they're saying to us that we must hence or otherwise determine the equation of the common tangent to the circle A and B. We have to find the equation of the common tangent. How do we do that? We have to draw that tangent we're talking about. So the tangent, the common tangent we're talking about here, it's going to pass through C, where C is the point of contact. Yes, so we're going to have the point of contact, which is going to be at C at that point. So I'll then say to myself, well, this is how I'll do that. I'll then say to myself, well, I want to find that equation. I can do it in many ways. I can use, because look, that tangent is perpendicular to this radius right here. It's perpendicular to that radius here. So I'm going to get that gradient, or I get that gradient. It's either way, it's fine. So allow me to get the gradient of the radius, any point between those. So I'm going to use the points between C and B. Either way, you can use AB. Allow me to use CB in that case. So now I'm gonna say I have a point B. No, I'm gonna write C first. I'm gonna write C first, which is going to be that is 20 over 13, and you have 95 over 13, and you also have a B there. A B, you have what as a point? You have that was 8 and 10 for B. You have 8 and 10. What I will then do is I'm going to try and find the radius, the gradient between these 2 points. Sorry about that. So I'm going to say, well, the gradient between BC is going to be BC is going to be YC minus YB divided by XC minus XB in that case. So we'll then say to ourselves, well, this is equals to what is YC? YC it's 95 over 13 minus Y at B, that is 10, divided by XC, that is 20 over 13 minus 8 in that case. So let's see what we're going to have there. We're still going to get 5 over 13. 5 over, it's 5 over 12 in that case. It's 5 over 12. So this is the gradient of what of the radius. This will then mean that the gradient of the radius multiplied by the gradient of the tangent, they're going to give us -1. So this means that the gradient of the tangent is what? It's minus 12 over 5. It's minus 12 over 5. Okay, and then what I'll now do is I'm going to get the equation itself. So how do I get that? Very simple. We say, well, this is y equals to mx plus c, where m is minus 12 over 5 now. So I'm going to say, well, y equals to minus 12 over 5 x plus c. I'm going to write at a point C, where C is the point of contact. That is going to be 20 over 13. You have 95 over 13. Why am I using the point C? Is because this is the only point I have at the point of contact where the tangent passes through. So I'm gonna substitute those points into this line right here. Let's see what we get. We'll now then say, well, this is 95 for y over 13 equals to minus 12 over 5 into x. X is 20 over 13 plus c. So this will then give us the value of c. If you try and solve that, you're going to get positive 11. So now we'll then say to ourselves, therefore, the value of, the equation of the tangent is going to be given by, the gradient, which is -12 over 5x plus 11. This is the equation of the tangent, the common tangent to be specific. This is what we have right here. Thank you very much.